Okay. Thank you for listening, and thank you all. Thank you for the chairs. So my presentation today is about the preliminary study and about the wireless sensor with the BLE. Okay. So now sensors with wireless is very popular and used a lot. And wireless sensor and or sensor network is widely used, and aim is to design a cost-effective and dynamically scalable, or either to deploy and either to connect to the network. So Wi-Fi, Zigbee, and Bluetooth are the three main wireless technologies used today for our sensor. But now there are still some challenge for this kind of wireless technology, such as for the Wi-Fi, we still consume a lot of energy, and for the Zigbee, it's not easier to connect to the network, and for the Bluetooth before 4.0, they still take a long time for the connection and consume more energy. So the BLE, also called Bluetooth 4.0, is created and by the SIG. And the aim of BLE is to transmit a small data with very low power. So in this case, the sensor could be with the wireless ability and consume very limited energy. However, for the BLE, the biggest limitation is the size for one transmission is still about 20 bytes. So it's used to transmit very small data. But the advantage is for use the BLE wireless, all the sensors could be easily connected with our smartphone, so it's easily to connect to the network. So we can say BLE is a very promising wireless technology for our wireless sensor. So in our research, we need to do to use the BLE to aggregate the data for the real time or collect the data continuously. For example, such as the wearable heart monitoring sensors, we need to use the sensor to monitor the state of the heart all the time, and cannot be and the heart would create the sensor of the heart would be create data and continuously. And for our objective, we're going to create a new strategy which we can use the BLE to transmit more data just than 20 bytes. So we need to use a new strategy and to do that. And we're going to use the wireless sensor for our daily activity monitoring. So first, I'd like to have a brief introduction about the BLE data transmission. And for the BLE, we have different, we have one we call is master, just like our smartphone is which can inquiry all the sensors nearby. Another one is we call it a slave. And slave is will respond to the master if he get any signals. So first, the master would encourage to see if any sensors nearby. And when the sensors get the inquiry of the master, he would respond. And this is the first step. And after that, the master and the slave, they have connect, and the master would transmit the channel access code and the clock to the slave. So in this case, the master and the slave would be have the same clock, and the slave would know when to transmit the data to the master next time. So that is after that, the master and the slave are connected. So in that, after they connect, the master would transmit the inquiry periodically to the slave, and the slave would respond to every inquiry. So this is the 7 different status for the BLE, and the standby is the default state, and the inquiry state is used to discover the new device just for the master, and the paging substate is used to establish new connection. And if they connect, they work at the state of the connection. So in the state of the connection, the master and the slave, they are transmitting with a different interval, with different unit. We call it unit. And the one basic unit is 1.25 milliseconds. So so every data would transmit in this unit, and also the master and can inquiry in a interval, which is the integrate number of the unit. So and it's a range between 7.5 to 4 seconds. So that should be larger than the basic unit, 1.25 milliseconds. So in our design, we have to use the 1 unit, because every unit, time unit, we can transmit data to 20 bytes. So as in our research, we transmit the sensor data 3 bytes every time. So we can use 6 this kind of sensor, just 18 bytes. This can be used for 1 unit. And in this case, we can reduce the energy firstly, and then if we can transmit more data than 18 bytes, we have to transmit more units. So we for every 1 interval or 1 transmission cycle, we can transmit a multiple unit as a 1 package. So in this case, we're going to explore if we increase the number of the M, how about the energy consumption would change. So this is the 3 basic formulation we use to calculate theoretically, and the average current can be calculated by the charge and divided by the time, and the time can be calculated by the number of the data and the sampling frequency, and finally, and the Q can be calculated by the actually this is the charge of the sampling, and this is the charge of transmission, and this is the charge of the sleeving. So we can calculate the final average current from this formulation. And I'm sorry, there is a type mistake. So here in this equation, the frequency and the C are the constant, and finally the charge for the transmission is increased very limited. So when we increase the number of M, the average current would decrease. So finally, we do the experiment to see what the energy would change. We use the Bluetooth 4 chips of TI, CC 225 and 41, and the Nordic the 1822 to compare in this experiment. We have a data log to collect the data, and this is the sensor with different with these 2 chips, and we use a oscilloscope to collect the waveform of the current. Actually, it's the voltage. Yeah. So we can use the this equation to calculate the current, the charge by to make an integer of the voltage, and then we can calculate the average current by dividing by the interval terms. Okay, so this is the result if we just increase the number in 1 unit. Okay, 1 unit, the biggest is 20 bytes, so we have 6 in 1 unit, and we can see that the average current is decreased from 0.5 mA to 0.1. Okay, that is obviously, and then we calculate the current when we increase the number of the unit. We increase the number, and this is the experiment result of the TI chip, and we can see that for the current from 1 to 10, it's decreased about 40 percentage, and after that the energy consumption is very stable. And I have to see that when the number is larger than 16, the transmission is not stable anymore. So this is the result with the chip of Nordic, and we can only make yes, the largest number is 7. So the average current is decreased almost the same, about 14 percentage. So we have get the results that use the data packaging transmission, we can decrease 40% of energy consumption for the BLE chip, and also we have a maximum of this number because of the protocol and or the chip, so it's cannot be too much too large. So use this data packaging method, we can make this wireless sensor and have decreased the energy consumption, and this makes the sensor be more suitable for continuous real-time data acquisition. And also, and the Bluetooth 4.2 is disappeared and just used to solve this problem, and the biggest the change is it can be transmit more data, nearly about 10 times more than the previous one, and so that would be more better for the real-time sensor monitoring. However, we can also use this kind of data packaging method to decrease the energy consumption. Okay, thank you.